Okay, now we'll talk about the actual Monocurl language. So the language is custom in the sense that it's not anything else. It's not Python, it's not Java. There's significant differences. However, it is relatively simple, so I think if you have any programming experience, hopefully it should be pretty easy to follow. I will say though that do assume some level of experience before, so some of this stuff might not make full sense if you don't. But even then, I did think it's relatively simple, so hopefully should be somewhat easy to follow. All right, in terms of the basics, I'll kind of skim over these because this is not super interesting, but we have a few different fundamental data types. We have doubles, which is just numbers, vectors, lists, then we have strings and characters. Strings and characters aren't actually used that much. Then we have a map, and then we have a mesh, animation, and then function and functors I'll talk about in a second. Alright, so we can declare variables using var or let. Var allows us to make it mutable, let is to make it a constant, and then we also have control flow through if else and for loops, as well as while loops. There's the standard operators. I'll skim over most of these. There is also exponentiation, but the one thing I do want to point out is that whenever we have vectors, addition is not how you might typically see it. In particular, if you have 0, 1, 2, and then we add 3 to it, it's going to evaluate to 0, 1, 2, 3. So in particular, it's not actually vector addition in the math sense, where we would add 3 to everything, but it's also not really list concatenation because we're not saying 0, 1, 2, and then concatenating 3. That wouldn't really make sense. That's more apparent in this example where this last list it just becomes an element. And this actually just does make more sense based on how we use Monocurl. Okay, we do have also a range operator, but this is a bit ugly. I might change that in the future. Okay, so that's some of the basics. I think the basics are pretty easy to get a hang of. There are some important things that I do want to talk about, especially about the functions and the functors. So we can declare functions very easily. Monocurl takes inspiration from functional programming languages, so I want to make it very, very easy to declare functions and to call them. So here's an example. This is just going to be a determinant function. Pretty simple syntax, right? Okay. The other really intricate part about functions is that whenever we're capturing values, they have to be mutable. So whenever we have something that is mutable and we want to capture it, we'll have to copy it into a constant and then capture the constant instead of capturing the naively mutable value. Okay, that's more or less something that if you have any other experience with other languages should be relatively familiar, but this functors part is something that is unique to Monocurl as far as I know. Okay, so for some motivation, let's suppose that we have some circle creation function, right? We want to create a circle, and now we have the start state, but now I want to move the start state to the end state, so I'm going to have to create the circle creation function again. But notice that whenever we're doing these changes, more often than not, we're just going to change some one variable, right? So in here, we're literally just changing one. So it seems very, very redundant that we're going to have to say the same thing twice. Or almost same thing twice. We want to somehow have a way to say that end is exactly the same as the start, with the one exception being that the x value of the origin is changed. So this motivates functors. Functors are a way where we can call a function. I can call this function and it will remember, one, it'll remember the actual function that was called, and two, it'll remember the arguments that were passed in. So here's the syntax. We'll say the function name, and then we'll use a colon instead of parentheses, and then we'll have to specify the arguments. In fact, the editor does that for us most of the time, so you really just have to say 0, 0, 0, or 1. Okay, so now that we have a functor, but how does this help us? The way it helps us is that now I can say var end equals start, so I can copy the value of start and into end, and then I can change the center. I can change the center, and it's now a new circle. That's the key idea, is that it remembers the function that was called, so whenever we change any of the arguments, it recalculates the entire value of the function. Okay, so I think it might actually be helpful to look at this in terms of a concrete example. So we can do functors with any single function. That behavior might be changed in the future, but for now, that is what we can do. So even like with a user-defined function, like that determinant function we had, we can call it as a functor. So we can say orgdet equals 1001, so that's the identity matrix. So right now the determinant value is going to be 1. So that's the thing about functors, is that you can think about them as wrapping the value, right? So the underlying value of orgdet is 1, but somehow it still remembers that it was created using the determinant function with these parameters. So now when we say newdet, it's still going to underlyingly have a value of 1, but it remembers how it's called. And then if we change a to be 2, it'll remember how it's called, or it'll remember the function, so it can recalculate its value to 2. And then if we change d to be 2, now it'll recalculate its value to be 4. In other ways, though, this newdet kind of acts like a number. It just has this extra information, has this extra type information associated with it. All right, one thing I also did forget to mention, though, is that Monocurl is entirely copied by value. So whenever we have this end equals start, you can think of it as doing a deep copy. So this end.center will never affect start, right? Okay. Other important things is that whenever we have this syntax, we can actually have sub-expressions within here. This is somewhat of a toy example. Obviously, we could have just inlined these values, but the point being that you can change even global state within this thing, or within the initialization body, which is pretty useful if the actual arguments to here get more and more complex. Oh, of course, over here it's relatively simple, but this is just a toy example. Okay, the final point about functors that is very important is that we can use them to do sub-expressions. So notice that in the function, when we have the function here, function declaration, we have to say func that equals some expression. But what if we want to have an expression that's more and more lines? Most languages will just have braces, but I just wanted to keep compiler simple, so the way that it's done in Monocurl, for now at least, is that we can use the fact that we can have sub-expressions to basically, we can use the fact that we have sub-expressions and functors to insert sub-expressions into a functor, and then we can return the value. All right, that was a bit wordy, but the high-level idea is, well, what if we have a functor that basically does nothing with its input, so identity functor, and then now that I'm calling a functor, I can do sub-expressions, and then I can basically return it. So the identity functor is basically going to do nothing. So if you really want to think about it, this is basically just doing, it's a very, very elaborate way to do a return statement, but it does make the language somewhat simpler because now there's only one uniform method. Again, I might change this in the future, but for now that's how it is. All right, one other thing to point out though is that some functors, they take in multiple modes. So let's just actually see an example of that right now. So I have the circle and then we have the color as default. So there's a branch that says default, we can't even change that. But maybe I can change the stroke, so I can go to a different mode where I specify the stroke. And then we can see that we change the color, and then I can even go one step further. So just by clicking these, we can cycle through the different modes. I think it is somewhat buggy right now, but more often than not, it should do the job. So this is the preferred method rather than typing it out, whatever. Like if we wanted to type it out, that's typically just gonna, glitch out. So I would recommend just clicking on the buttons. It does get somewhat repetitive, but that's the best method. All right, as long as you understand the idea behind functors and some stuff about functions, I think you probably should have a good enough idea of the language, at least for